All right, guys, in this video we're going to talk about the difference between empirical and molecular formulas. Now, in the last video you were talking about questions that look like this, except they were slightly different. They might tell you 77.9% aluminum and 139% of sulfur, and you'd work the problem out. But they don't always give it to you in percents. What was the first thing that you did when you had 77.9% aluminum? The very first thing you did was you made it 77.9 grams of aluminum, and then you start working the problem. Convert to moles and you work. Well, notice in this question that they gave you a start place that's already in grams. So you already know how to do this. You just don't have to deal with the percentage. So the very first thing you're going to do is make your railroad tracks grams to moles. Grams to moles. The number 1 always goes with moles. Grams are off the periodic table. Aluminum is 27 and sulfur is 32. So I take my handy dandy calculator and I'm going to take 77.9 divided by 27, and that is an answer of 2.89. 2.89 what? Moles. And this one, 139 divided by 32 equals 4.34 moles. Now, what do you do next? Well, you got to find out the ratio of that to that, so you find the smallest one, divide them both by 2.89. So that becomes 1. And 4.34 divided by 2.89 is exactly 1.5. So when I have 1.5, great. So the ratio should be AL1 to S1.5, but we know that we never have formulas that look like that. So whenever you have a 0.5, that means a half. How do you get rid of a half? You get rid of a half by multiplying by 2. So you're going to multiply them both by, not an equal sign, both by 2. So your ratio comes out to a 2 to 3 ratio. So your formula is AL2S3. And you saw that in the other video. It's not very difficult. If you came out with a whole number here and a whole number here, then that's your answer. But if you have a 0.3, that's a third, then you would multiply everything by 3 to get rid of a third. If you had a 0.25, which is a quarter, then you'd multiply by 4. It's just a way to get solid whole numbers, so the ratio between aluminum and sulfur in this compound is a 2 to 3 ratio. Now, that's an empirical formula. What's an empirical formula? If I look at this formula, I cannot reduce this formula down. Now, we learned early in the year that there were things like this: C2H4, C3H6, C4H8, C5H10. Those things were called ethene, propene, butene, and pentene. Okay, that's great. But look at the formula: C2H4, C3H6, C4H8, C5H10. If I'm correct, they all come from this basic formula, right? I could actually reduce it, and it would all reduce down to C1H2. Okay, an empirical formula is as its lowest ratio. So this is the empirical formula. These are molecular formulas. They're all versions of, so think of it like this. This is the skeleton, C1H2. Every one of those is that skeleton. This has a little extra meat on it. That has more and more and more. So this is an empirical formula. So how do you think they get these things? Okay, very simply, here's what they do. In a problem, they would tell you something like, okay, you've got 77.9 grams of aluminum, 139 grams of sulfur, and at the lab, they found that it weighs 300 grams per mole. So they know how much the compound weighs. Okay, so anytime you see a weight, you know you're going to do an extra step. So all the math that I've already done here is correct. Now, when I get my empirical formula, all I need to know is how much does my skeleton weigh? Because, see, I can't reduce that. So this is an empirical formula. This is 27 times 2 is 54. This is 32 times 3 is 96. Add those together, it's 150 grams. Perfect. So my skeleton weighs 150, but the lab said it should weigh 300. It weighs 300 in the lab. So what does that tell you? Is this the formula? No, but that's the skeleton. How many times does 150 go into 300? 2 times. So it should be double this. So the molecular formula, it's to be double that, it has to be double the numbers. Al2S3 becomes Al4 S6. This is an empirical formula because I cannot reduce the numbers. When I know how much it's supposed to weigh, I take that skeleton, weigh the skeleton. How many times does the skeleton fit into what it actually weighs? Then I would have had it. Okay, so if this was 150, let's say in the lab they told me that it weighs 450 grams. Not 300, but it weighed 450 grams. That's fine. Okay, the skeleton still weighs 150. How many times does 150 go into 450? The answer is 3. So it should be 3 times that formula. So what would be the formula? Come on, pen, Al6S9. That would be the molecular formula. So how do I know the difference between an empirical formula and a molecular formula? Empirical formulas, I do all the math. It's the skeleton equation that I get. That's an empirical formula. When they tell me how much it weighs, I do one more step. How many times does the skeleton fit into that? And I have the molecular formula. Now, one more scenario. What if they would have told me in the lab that it weighs 150 grams? So they take it to the lab, they run it through a spectrometer, and they know how many grams. They calculate out its formula. There it is, Al2S3, perfect. And then it weighs 150, but they tell me it's supposed to weigh 150. So what's the formula of the real compound? That, Al2S3. And so since it's Al2S3, that is the empirical and the molecular in this case. You're going to be practicing skill on an upcoming worksheet. It's not too hard, empirical versus molecular formulas.